How often do you think about space? Probably not enough, considering how much we use it every day. We rely on thousands of satellites up there to keep our modern lives running smoothly. But there is an explosive threat approaching on the horizon: space junk. Satellites up in the space beam TV signals and phone calls around the world. They facilitate Google Maps, GPS, and the internet, bank transactions, the stock market, disaster planning, military surveillance, and air traffic control. They help predict weather phenomena and crop farming. They provide data on the oceans, outer space, and global warming. And that's just a few examples. Every day, more and more satellites are launched into orbit. While they provide invaluable services, they also leave behind a trail of debris, spent rocket stages, defunct satellites, and countless smaller fragments. These debris poses a significant threat to operational satellites. A collision, even with a tiny piece of debris, can be catastrophic. It can generate a cascade of new debris, creating a chain reaction that could render large swaths of orbit unusable. Scientists and engineers are working tirelessly to address this growing issue. Companies like ForumIAS and Leo Labs are tracking debris and issuing warnings to satellite operators. Other companies like ClearSpace and Astroscale are developing innovative technologies to actively remove debris from orbit. The concept of Kessler syndrome is a frightening possibility. If we don't act soon, we could reach a tipping point where the amount of debris is so high that collisions become irreversible, creating a self-perpetuating cycle. But this is not. Most satellites fall back to Earth burning up in the atmosphere. It's a fiery farewell, but not a clean one. As these satellites disintegrate, they release pollutants into the upper atmosphere, and the effects are starting to raise serious concerns among scientists. According to a study by scientists, 10% of aerosol particles in the stratosphere contain metals like aluminium, metals originating from the burn-up of satellites and rocket stages during re-entry. According to a study by scientists, aluminium and nitrogen oxide emissions from satellites re-entries jumped from 3.3 billion grams in 2020 to 5.6 billion grams in 2022. And it's not just satellites. Rocket launches themselves contribute pollutants like black carbon, nitrogen oxides, and chlorine gases, chemicals that wreak havoc in the stratosphere. Now you might be thinking, this is all happening high up in the atmosphere. How does it affect us? The answer lies in the critical layer of our planet, the ozone layer. The ozone layer absorbs 99% of sun's harmful ultraviolet rays, protecting life on the Earth. But pollutants like aluminum oxide from burning satellite act as a catalyst for ozone depletion. Scientists fear that this could undermine the progress we have made since 1987 Montreal Protocol, which successfully phased out ozone-depleting chemicals like CFCs. Now the question arises, why this matters now? Life on the Earth has evolved in harmony with our planet's environment. Even tiny changes in atmospheric chemistry could create ripple effects, affecting weather patterns, ecosystems, and human health. We are at a crossroads. As we expand our presence in space, we must also address its unintended consequences on our home planet. So what's the solution? Scientists are exploring cleaner technologies for satellites and rockets. But awareness is the first step. Governments, industries, and individuals must work together to ensure our quest for progress doesn't come at the cost of Earth's fragile balance.